Alright, so we're going to find the total number of squares here, and also I'm going to develop a general formula that you can use for any size square to find the total number of possible squares. And keep in mind that I'm not just talking about the non-overlapping squares or these cells. I'm talking about every single possible square. Like how many of these squares, how many of these squares are there, how many of these squares are there, right? So every single possible size contained within the square, how many of them a combined total are there? All right, so there will be a general formula that we're going to use for that. The best way to start is to draw a diagonal line. All right, now this diagonal line will help us determine what sizes of the squares we're talking about when we're trying to count them. So the first thing to do is to basically draw this vertex and then start with this vertex. So we're talking about the smallest possible squares first, right? And that's going to be the non-overlapping squares, as you can see. Right? So how many are there? The formula is easy, right? You basically, since this large size, the largest possible figure is a square itself, you know that the number of rows and the number of columns agree. They're both equal to 8, right? So we know that the first size, the smallest size squares, there are going to be 8 times 8, which is 64, right? So 64 of them will be contained in this square of these smallest sizes. Put a second vertex here. We know that we're talking about this size square now, right? How many of this are there? Now notice that, again, this vertex helps us locate how many translations we can have of the square across and how many translations we can have it below. And again, using the product rule, we can determine without counting every single translation across and below by just multiplying the number of translations across and below. So that's going to be one fewer than it was before, right? Because it's going to be 7 places and 7 places across and 7 below, right? So it's going to be 7 times 7, which is equal to 49. And as you can see, you're definitely talking about perfect squares, right? Because if you increase the size to 3 by 3, you will see that it's going to be 6 times 6 possible translations, right? So there will be 36 possible squares contained within this largest square of the size of 3 by 3. So that means you don't really have to go all the way. You can just write 5 times 5, 25 of the next largest size, and then 16 more of the even larger one. Then we have 3 times 3, 9, 2 times 2, 4, and finally 1 times 1 will give us 1, right? And that's the largest possible square that you see. There are no translations allowed, because this largest square is contained within itself, right? It's circumscribed or inscribed, however you want to call it, in itself, so there's no way for it to have any more versions than just one. All right, so now as you can see, there is a pattern. There is a pattern that we can use to develop a formula to find the total number of squares for any size square, right? Because what if your size n, for example, is not 8, the largest number, but it would be 1,000, right? If we let n being equal to 8, the sum, we can express it as n squared plus, and then the next one we're subtracting 1 from n, right? Because if n is 8, n minus 1 will be 7. So that means we're going to do n minus 1 being squared, then n minus 2 being squared, because we're always subtracting 1 from the number before that. Right, and all the way until we get to n minus k squared. All right, now notice that n and k are integers. That's very important, or whole numbers, however you want to call them, with k being equal to n minus 1. Now, why is that important? It's because when we get to the very last term, k should be exactly 1 fewer than n. Right, because to get to 1 from 8, we need to subtract 7 from 8. Right, so n minus 1 is the value of k, because when you subtract that 7, you get n minus k, which is equal to 1, and you square that to get the 1 times 1 is equal to 1. When you're adding the squares from 1 to n squared, basically, you just have to do the summation formula, which is going to be what? Which is going to be n times n plus 1 times 2n plus 1, and that should be divided by 6. All right, a very powerful formula that can actually give us any size n largest square to find the total number of squares contained within it of any size, including itself. All right, so let's test this formula. So we're going to set n is equal to 8 because that's the number of rows and also the number of columns of these smaller squares, right? So n is equal to 8. So now if we test it, we're going to get ourselves, using the formula, 8 times 9 times twice 8. Twice 8 is 16. So we're going to get 17 if we add one more to that. And then we're going to divide that by 6. Should be 1,224 divided by 6, which will give us exactly 204 squares. Now notice if we add these up, these numbers, we will get 204 squares as well. All right, so we found a formula that actually agrees with the manual counting method. Thank you so much for watching. I hope this formula is going to help you out.